Assalamualaikum. My name is Nur Fazlin, CE190107, and my other two teammates is Nur Shaliza and Nur Nabiha. So I'm going to do some introduction about the intrinsic and distortion coefficient parameter determination from the smartphones. So next. For the introduction, calibration is a process of estimating intrinsic and extrinsic parameter. Intrinsic parameter is about camera internal characteristics such as focal length, distortion, and image center. And extrinsic parameters describes the position and orientation in the world. Types of smartphone that we use and our result. Okay. So for the first one is iPhone 7 Plus. Nur Nabiha used iPhone 7 Plus, and we can see this is the result that she get. This is the result when she do the distortion after distortion is removed. So as you can see here, this is Nabiha's result before distortion, and this is after distortion. We can see that after distortion, many distortion were removed, and this is the extrinsic parameter that we can see using her phone when she do the simulation. The second one is Vivo Y15. Vivo Y15 is the types of phone that I'm using to snap the samples. So as you can see here, this is the parameter, the calibration parameter, and the calibration result after the optimizations. This value shows the value of distortion, which is 000, almost no distortion. This is also the distortion is very low. The value is very small. So we can see here, this is my extrinsic and reprojection error here. This is my picture, the result that I get from before the distortion, and this is after the distortion. And lastly is Realme C2. Realme C2 is the types of phone that Shaliza use. Here we can see the calibration parameter and calibration result for optimization. Okay, using Shaliza's phone, this is the one that she get the samples from the chatbot. This is before the distortion, and this is after all of the procedures done, which is after the distortion. Here is the extrinsic parameter in camera and world centered. Hi, so I'm going to continue with the demonstration. I'm going to be the first demonstrator, so here we go. So first of all, I'm using MATLAB, and I will go to just now I go to the Google and to download the toolbox_Calib. Toolbox_Calib is not in the toolbox in the library, so I need to download it online. So after I download, I browse the file and to show it here, so it will appear here. So for the first step, I'm going to put the coding, which is Calib _ GUI. Oh, sorry, here typo _ GUI. So enter. So this calibration toolbox, camera calibration toolbox, will appear. So we choose standard for all the images are stored in memory, and then choose extract grid corner. Okay, you can see here. So here, best name camera calibration image without number. Just now in the files, the toolbox that I've downloaded from the Google, I put it into the local disk. So I've captured 10 samples of the chat box, and I copy it and paste it here in the same folder. So the name of the sample is sample 1 until sample 10. So back to the MATLAB. Base name camera calibration image without number or suffix. So it's meaning, the meaning is here. Okay, sample 1. So without my number for the my names for the sample, my sample's name. So put it without the number. So enter sample here. Enter, and then the types of the sample image. So JPG. It will loading the image. Okay, done. Okay, here. Okay, we can see here 10 samples here. This is all of the samples that I take using my phones, which is Vivo Y15. And then, okay. Okay. So we are going to calibrate all of the picture, all of the samples. So we go to here and then extract grid corner. Extract grid corner and extract grid corner, and then enter. Okay, until here. Okay, processing image 1. So this is figure to show my image 1. So I need to do the calibration, and I'm not only going to do the calibration for one samples, but for all of the sample, which means all of the 10 samples. Yes, so I'm going to select several corner to do the calibration, for the distortion. So I've done, and then okay. So here's the result. Using the same step to calibrate the sample number 1, we use the same step to calibrate all of the samples, sample number 1 until sample number 10. So here we I've done calibrate all of the samples, and it show the corner extraction done. So the next step is I'm going to analyze the error. Okay, no calibration data available because I've done it just now. So here I'm going to show you the result. After I've done the representation error in pixels, here's what I got the result. This is my own result that I've done just now. So we can see here there will appear a new image of the samples without the distortion. So we can see here this is the image before we do the calibration, and this is all of this image, the samples after we done the calibration and without the distortion. It will rename it as sample underscore rec1.bmp. So this is what I've done just now. For the error, this is what we'll show. This is what we will show after we do the error, and then the parameter will appear here. You can see here the distortion is 0, 0, 0, and the pixel error and the distortion here is 0.1 something, and it's still in 0 point something. So it shows that the distortion is small. And then after that, the next step is I'm going to do the I export the calib data, and then I show the extrinsics to make it. I show the extrinsic. This is what you get. And then to get the world-centered view, this is the result for the world-centered view for the extrinsic parameter. So I'm going to show the result after the distortion process, after the calibration process. Here, the one with the colored one is my sample from sample 1 to sample 10. Then after the calibration, after the distortion is removed, this is what we get, the black and white color one. So we can see here the distortion is removed and the picture is more clear. Yeah. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Nurnabiha binti Muhammadiyah and my metric number CE190179. So I'm going to demonstrate about the camera calibration using MATLAB software. So first, I have downloaded the Toolbox calibration in the internet, and I paste it in the C, and you can see all the folder here. And I also took a pictures, which is 10 sample using my device, which is iPhone 7 Plus, and I name it as my name, Nabiha 1 until 10. So next, we go to the MATLAB, and we need to select the folder. We select the folder, and then we just type calib_GUI and press enter, and we need to click the standard one, which is all the image are stored in the memory, and pick the image name. So as I said before, my picture's name is my name. We just put the base name. First name is Nabiha, and then press enter. The type of file is JPEG, and enter again. And now it will load all my sample image. So this is my sample pictures, 1 until 10. And then I will click on the extract grid corners, and this is the number of image. I just press enter. Then if I want to use default, I can use default, but I will use file instead. And then enter again. Enter. So I have to extract the grid corner for each of the sample image. This is my first picture. Then I just press enter, and it shows the size between the square box, and press enter, and it's detect the box, and enter again. And then the second image that I have to extract the grid, and all the procedure need to repeat until the last image. Next image. Okay. Do it again. Enter. Next image. Press enter again. Press enter. Press enter again. And then after it's all done, I need to do a calibration. Just click the box of calibration. You can see the value, the number of skew, distortion and pixels error. And then I just to click the show the asterisk. And as you can see here, this is where my camera location. This is for train 6 where my camera located, and we can see the image, the location of the image that I took, the 10 samples. We can see the 10 samples of location, and then we can switch to the world center view. Okay. Next, we can use, this is the image that I took, located that I took, which have 10 samples that we can see. So next step, we just need to undistort the image and click the box undistorted, and then just enter. And we need to wait to save the undistorted image, and it will save at toolbox folder all the undistorted image. We can see after all the image have saved in the folder, then we can see from the folder the undistorted image. Just click and we can see all the different. This is the first picture, number two pictures, 3, 4, 5, 6, 7, and this is the first image that I have took, the original image. And that's all for me, and thank you.
Assalamualaikum. My name is Nurshaliza binti Abdul Halim. Okay, today I will present about the calibration of camera. Okay, first of all, I will explain about the theory for calibration, for camera calibration. Okay, camera calibration is the process of estimating intrinsic or extrinsic parameter. Intrinsic parameter camera internal characteristics such as focal length, screw distortion, and also image center. Okay, next for extrinsic parameter, it will describe about the position and orientation in the world. Okay, so as you can see, this is the sample of checkboard picture that I will take with my phone. Okay, we have 10 sample of picture. Okay, first we need to copy this picture and then we need to paste this sample of picture in toolbox calibration. Okay, and then next we open the MATLAB. Okay, so we use the MATLAB to do this experiment. Okay, first we need to write the calib GUI, calib_GUI. This is the command for this camera calibration. Okay, after that it will appear this thing. Okay, so next we need to click image name. So when we click this, the command will appear like this. Okay, so this is the command for image. Okay, next, okay, this is the sample for our picture. Okay, next, baseline camera calibration. Okay, this we just need to write the code for our sample. Like this, for example, color 9. Okay, so we just need to write the color. Okay, next, image format, JPG. Okay, and then we click enter. So the image so the coding will run for loading image. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sample of picture. Okay, when we it done. Okay, so okay, it will show the figure like this. Okay, so this is 10 sample of picture, of checkboard picture that I just took with my phone. Okay, next, we need to know the extract grid corner. Okay, so we just click extract grid corner. Okay, and then, okay, so it will appear for coding like this. We just press enter, and then enter. Okay, so this is the command that appear. Okay, so we need to do the what we call the okay, we need to find the distance for this square from four corner. Okay, so we just click enter. Okay, so this is the process image for image 1. Okay, so the first step is we just need to click the corner for the picture that we want. Okay, for example, I just click at this corner. Okay, 1. Okay. Next, 2. 3 and 4. Okay, done. Okay, so as you can see, Okay, this is the y-axis and x-axis for sample picture 1. Okay, next we have 10 sample of picture, and then we must repeat this step for all the 10 picture. Okay, so we just click enter. Next, this is the sample 2. We just repeat the same step until sample 10. Okay, write the 4 corner of sample. Okay, done. Then we just click next for sample 3. Okay, this is sample 3. 1, 2, 3, and 4. Okay, so next we just click enter for the next picture. Okay, this is sample 4. 1, 2, 3, and 4. Okay, so enter. The same step for all the sample. Okay, and then 4. Okay, so enter. Okay, this is sample 6. Okay, 1, 2, 3, and 4. Okay, so we just click enter for the next picture. Okay, sorry. This is sample 7. 1, 2, 3, and 4. Okay, so click next for sample 8. Okay, delete. Okay, sample 8. 1, 2, 3, and 4. Okay, you can see they have dy, dx. Okay, this is y-axis and this is x-axis. Okay, next. Okay, this is our sample of sample 9 sample. 1, 2, 3, and 4. Okay, so next. Okay, so this is the 1, 2, 3, and 4. Okay, so we've done for all 10 samples. Okay, so we just need to write. Okay, so this is done. Okay, next we want to calibration for this sample. Okay, we just click the calibration. Okay, so okay, we can see this is a calibration parameter after imperialization. Okay, this is focal length, principal point, screw distortion. Okay. Okay, we also can see the pixel error for this picture. Okay. Let's do that. Okay, next we just show the extrinsic. Okay, so this is our extrinsic. Okay, this is the meaning for this many square picture. This is the position when we took the position when we use this handphone to take the picture for checkbox. Okay, so we can switch to world center view. Okay, so this is my phone position when I took the picture for the sample checkbox. Okay, so you can see that they have 10 position of 10 sample of checkbox.
So just now we've done all of our demonstration from me, Shaliza and Nabihat. So we move to the last one, which is conclusion. This study aimed to analyze the accuracy of the image of smartphone to determine the three-dimensional position of close objects prior to the development of photogrammetric system. Prior to the accuracy assessment of smartphone camera calibrations was conducted to correct the lens distortion of each camera and the accuracy of the image coordinates. So the result analyzed depending on the considering the lens distortion coefficient was conducted. And then lastly is the result showed that in terms of distortion correction of smartphone camera, also higher order symmetric radial lens distortion coefficient should be considered. And three-dimensional position determined by smartphone image was a little difference from that biometric camera. So that's all from us. Thank you and Selamat Hari Raya.